Hello everybody, this is Itsu again, still hunting for the joke ferrite resonance. Yesterday I found that I have a natural resonance of the three coils around these values, the 15 turns below 1.66 megahertz, the 50 turns in the middle 1.294 megahertz, and the bifilar 150 output coil resonates at 153 kilohertz without any capacitors added, only the capacitance of the scope probe, which is about 17 picofarad. I will show you later on how I do this. But no resonance point found for the core, and today I had some nice replies again on my videos, and one of the replies was a method in trying to find the joke's ferrite resonance point, and as I understand it, it should be hooked up like this. In the middle we have the 15 and the 50 turns primary coil. On the outside the secondary, on the right side the secondary bifilar coil. At the bottom I have the copper strip attached to my function generator. And the two upper coils are connected to a potentiometer. The middle slider is going to the probe of the scope, and the bottom turns are going to the ground. I used several potentiometers. I have a 1K, or 100K, sorry, and I have a 5K. And this is how it looks in real life. The probe in the middle. The two green leads going to one side of the both coils, primary, and the bottom is joined together with the ground of the probe. And on the copper strip I have attached the function generator. It's still at 20 Hertz at the moment, a little bit more. And I have hooked up my scope to the both coils via the potentiometer, and I am in FFT mode, so I see now the spectrum, and the spectrum is about 12 megahertz wide. The center is 6.2 megahertz. Above this there's nothing interesting to see. So the only things I see now are a few spikes, and when I touch the pot meter, the spikes go higher. So I have some spikes over here. One is here at the midpoint, 6.2. The other one, I have to leave the pot meter now. Oops. Is around, let me touch the pot meter again, 7.3. And I have a big one in the beginning, which is around 1 megahertz. So these are the obvious peaks on the scope I see when I have the 20 Hertz running to the copper strip. When I now move the potentiometer left or right, nothing really is happening. The output varies a little bit, but I see nothing moving. No frequency going left or right. So the peaks are basically staying the same. put it in the middle again. So when I now zoom in a little bit to the one at the bottom and adjust it to the middle, I touch the potmeter again, you can see at the 1 megahertz there's a nice peak. It's not very sharp, so I think this could be it. It's very low, it's 1 megahertz, but the other ones are much higher. When I touch the coil, nothing really happens, just more output. So I'm not sure. So this is one of the first observations. So when I move the potmeter up and down, nothing really happens. Let me go back to the 6 megahertz range. Now I'm going to switch the wave generator to, what is it, 21k or 2 kilohertz at the beginning, 1 kilohertz, and I will slowly increase now. And you probably will see that this peak at 1 megahertz and also the other two on 6 and 7 are basically staying where they are. Only some noise and peaks later on for the frequency. I'm now at 10 kilohertz, 12 kilohertz. Now suddenly you see some more reaction. Again, the 1 megahertz peak is going up, the others are, well, staying the same. I will increase now the frequency. I'm now at 81 kilohertz. And now you see the individual peaks and spikes running fore and back over the screen, but basically the 1 megahertz peak stays where it is. Okay, I'm now at the maximum of my function generator, 2.9 megahertz. But you can see all the spikes moving forth and back, but the 1 megahertz stays the same. When I approach this 1 megahertz, to see if I can catch both the frequency counter, I'm now at 1.2 megahertz. When I approach the 1 megahertz, we suddenly see something very, very narrow. I have to fine tune. I see a lot of peaks now currently, all of each on 1 megahertz. I think they are all harmonics. I want to zoom in now to this 1 megahertz peak. I'm now at the middle 1.2, so I have to move it a little bit. So now I will tune and you can see that suddenly there is a match. I have to tune a little bit. It's exactly at 1 megahertz. My frequency is also there. With a slight detune, then it's gone. So, oops. So it seems to lock now at this frequency. I can expand the view, and I see a lot of peaks now all over the place. So it looks like I have some resonance point here, and it stays when I move the frequency around, lower it. So I guess I have found some resonance point here, probably from the ferrite, because this method I'm using now should cancel out the resonance of the different coils. So let me hear any comments, if possible, if this is what it should be. Well, that's it for now, for tonight. Thank you for watching. Short answer about how to measure the resonance of the coil. Like I showed before, the method I use is to hook a small 2 windings, 2 turns coil, small coil, pickup coil to the function generator. Couple it to the coil under test. In this case, just put it into the center of the yoke. Hook up the probe to the output of the coils. The coil. In this case, it's the 50 turn coil. And then I can use my function generator to sweep the range. Now 30 kilohertz and up. And I put in a square wave, so any resonance point will be a nice sine wave. You can see the harmonics already popping up somewhere. And this will be the resonance point for this 50 turn coil. I measured yesterday 1294 kilohertz and it's now 1333 roundabout. A little bit tuning. So this is how I normally measure the resonance of the natural resonance of my coils. I have of course a little bit capacitance of the probe, but I think it's very accurate. Okay, thank you.